Hi, welcome back to What's Next. Actually, we're having the second episode about artificial intelligence today. Let me introduce ourselves. I'm Ron Toledo. I'm CTO for Capgemini's Insights and Data Practice. And over here we have Marijn Marcus, your favorite data scientist. And today we'll be diving a little bit deeper into a very important aspect of artificial intelligence, machine learning. Now, before that, let's quickly recap what we've been doing in the first episode of this series. And if you haven't seen it, you may want to go there first. But we worked on a definition of artificial intelligence. And our definition of artificial intelligence was it's a collection of, let's say, behavior and capabilities shown by systems that are perceived by humans as intelligence. Now, the notion of perception is very crucial over here. It's first of all on a gliding scale, right? So what we perceive as intelligence might change over time. And because it's perception, it's best always if you define AI to mention examples. And a few of the examples that we've been discussing last time pertain to image and voice and video recognition. It pertains to conversational agents, natural language understanding, complex predictions, and autonomous systems. So many different areas of application of AI. And for us right now, the most effective way of defining AI, just mentioning examples. Now, one of the key notions of artificial intelligence is, of course, behavior and capabilities by systems, or machines, if you like. And these machines learn from data. And through that, they create their artificial intelligence or perception of intelligence as we see it. So we're here to discuss machine learning a bit more in detail today. Marijn, machine learning is not necessarily a new concept, but within AI, it seems to be the real engine behind the success of it. Could you tell a little bit more about the various flavors of machine learning?
Machine learning as a general field is indeed a series of techniques from computer science, mostly the most popular in artificial intelligence nowadays. It changed over time. To mention a few examples, there's supervised learning, that's classification or regression, predicting predefined classes like is this guy going to buy or not, is that house going to burn or not, or is that person going to default or not, or is that a picture of a cat or not. Whereas another field, unsupervised learning, like outlier detection, dimension reduction, concerns itself with fraud detection, finding outliers that evade the distribution, which also helps you cluster different groups, like you have different marketing, different groups within marketing, or even climate sciences, or even genetics, to bypass assumptions about classes and go into, what does the data show you about what clusters are there. Mm-hmm. Thirdly, reinforcement learning, which is basically a sub shape of the previous two. That's where you build a feedback loop into the system to let the algorithm train itself. Best example of that is, of course, AlphaGo, where the outcome of the match was fed back into the system to have it continuously train itself 24/7. Another example is Microsoft's bot from OpenAI that beat the world champion at Dota, an online video game.
And I also think Mrs. Pac-Man, the optimal score in the famous game Mrs. Pac-Man was also achieved through reinforcement learning, right? By a machine.
Too bad.
And too bad, but it was the optimal score and wasn't reachable, I guess, for humans, right? So that's machine learning, right? Using data to become better in, for example, predicting or explaining a situation, right? Rather than relying solely on logic and algorithms, but you learn from the data. Now, of course, machine learning is already around for some time, right? But arguably in the past, let's say 3 years, we've seen a breakthrough in the enthusiasm for AI and the things that we've achieved with AI. And there we hear a lot about neural networks and deep learning. And this is associated to machine learning. It's not necessarily 100% the same, right? Could you dive a little bit deeper into that as well?
Neural networks is one of the many and most popular machine learning techniques used nowadays. Mm-hmm. The big boom came around 2014 when NVIDIA figured out, we can use graphical processing units, GPUs, to run this stuff much, much faster. It stems in part from biology, genetic algorithms. emulating the functions of the brain and its neurons going through various steps of concrete to abstract levels of aggregation. Until some guy thought, man, we can have the neurons run in the other way as well, which is where backpropagation stems from. And deep learning specifically is a sub form of these neural networks.
Right.
One where you basically have a whole lot of neurons.
It's a whole lot of neurons, right? And it's actually a pattern matching machine, I guess, in terms of as long as you have a lot of input and output, right? Mm-hmm. And you're able to match it better and better through that neural network, right? And then there's several variants, of course, of these neural networks, right? Mm-hmm. How many layers they contain, how many nodes they contain.
Explicit or hidden.
Explicit or hidden. So there's all sorts of different variants of it, but essentially they're all the same, right? In terms of in being very different from machine learning as we've seen it so far, right? I've always compared it myself to a little child catching a ball. We've all learned catching a ball, although we can't remember because we were usually too little, I guess, to remember that. But the ball was thrown to us many different times, and we just couldn't catch it, of course, because we'd never done it before. And somehow we started to adjust ourselves and getting better and better at catching that ball. And sooner or later we were able to do it without an algorithm or a recipe or training material. We're just adjusting ourselves, turning all sorts of different levers and trying to get better and better in actually catching that ball until we could. And if you then would ask a child, how did you do it? You actually wouldn't be able to explain anymore, right? Just like you shouldn't ask a centipede, how do you actually walk with 1,000 legs, right? And still able to do it. And the moment you start asking, it would be like, I don't know, this is confusing, and maybe wouldn't be able to do it anymore. And that's fascinating about deep learning, right? And what are the areas where we've seen particularly the breakthrough through deep learning? We mentioned a few applications just now, but...
Well, image recognition is a big example of it. Partially developed by Google by a guy who wanted to classify images as is that a cat or not. It's being used in radiology nowadays to detect detect cancer in images. It's being used in various fields like audio, but also predictive. Natural language is another. The interesting part that you just mentioned is that when a human learns something, we don't really know how we do it, but that's fine. But when a computer does it, we want the logic behind it to be explicit. And that's the paradigm shift within deep learning, in that we can only really check the outcome, whether it's correct empirically. And we have much less to say about how it's working theoretically. There are Line models and stuff to alleviate those issues, but at the very core there is a shift from explainability, which relates to GDPR, but on the other hand, sometimes all you need is a good result, meaning context is of the essence.
Exactly, but it is a cultural shift for many people, because here's that centipede or that child catching a ball, no longer able to explain how it actually did it, but it works and it's very accurate. And so we sort of need to learn ourselves, maybe every now and then, to rely on that and simply go with the fact that we get a more accurate prediction or more accurate behavior or a more appropriate reaction without actually being able to understand exactly how it is done. Because there is no algorithm, there's no logic, there's no statistics as we understand it, right?
There's logic to a certain extent, but in a different way. The major question is, for some fields it's unacceptable, and for other fields it's actually not too bad. When you want to detect fires, you don't care how you detect fires, you just want to make sure you detect fires as quickly and as accurately as possible.
Exactly. So there's two different ways of recognizing a cat as well, if I understand you well, right? Because machine learning, you could teach it through algorithms what a cat could look like, or you simply feed it with 100,000 pictures of cats, and it's probably much more accurate in recognizing the next cat, although it would never describe what a cat is, right?
Until you change a few pixels and everything turns into a flamingo.
Yeah. Well, cats certainly resemble flamingos every now and then.
Oh, I didn't.
Except for the color, of course. So that's machine learning in different flavors, and it's clearly the engine behind artificial intelligence as we know it. And then, of course, artificial intelligence, and with that machine learning, is also the fuel to many of the digital drivers that we might consider adjacent areas to artificial intelligence. For example, big data.
Large quality and quantity of data being a necessity for most forms of machine learning. Yes, big data is very much related.
Very much related to it, obviously, and the ability to collect a lot of data in structured and unstructured format, be able to ingest it, to store it, to access it quickly. I think all are foundations for the current breakthrough in artificial intelligence as well, right? We discussed the automation last time.
Automation being the end result of many current applications of AI. Improving processes, facilitating them, speeding them up, having the user move from having to deal with the rule to only needing to manage the exceptions.
Yeah, exactly. So that's an important area. By the way, we have, of course, different flavors of automation, right? It can be as simple as robotic process automation, in which you simply look at a process and you sort of automate very, very, clearly robotic steps in it, all the way up to very smart automation, and then deep learning could get involved as well, right? And we get very typical cognitive capabilities that are part of the process that could be done very efficiently through a, let's say, deep learning neural network-based solution as well, right? And security, for example, cybersecurity, another, by the way, crucial topic in our series. What's Next series soon?
Data poisoning is becoming a thing in that you in that you input false information into a system to lower the accuracy score, and well, we're using learning methods to check for fraud nowadays, and that's a way to bypass security.
And sometimes, of course, the disease is also the medicine, right? With AI nowadays, we can create fake news, or fake audio, and the question, of course, is how can we battle that? How can we distinguish what is real from fake anymore? If advanced deep learning algorithms actually enable us to create it as well. And I guess that's a little bit the same case in security as well, right?
Yeah, which brings us to one of the limitations of deep learning, in that it cannot infer causal relationships, for example, which in an end state of almighty strong AI would be a necessity.
Yeah. Well, maybe we're not looking for almighty strong AI anytime soon.
We have movies for that.
I guess exactly. Better keep it in the movies for now. Now, you're a data scientist, and data science is obviously an area which is very much touched by this breakthrough in neural networks and deep learning as well, and machine learning. Would you think that all data scientists right now are already properly equipped to take advantage of this new wave in machine learning as well?
It's one of the fastest moving waves. So I would say no, because we have a whole lot of learning to do and a whole lot of stuff to do just to keep up with science progressing like that, and we're running like that. Plus, we always have the issue of we start building a model and we run it, and the first outcome is always the same, in that it's after which the real work starts in improving the model, adjusting the weights, seeing how many neurons you need. And that's where the real work is, and that's a misconception I tried to fight. We put the data in, and then we're not done. Then the real work starts.
The real work starts, exactly. It's adjusting and configuring and tuning the whole
right
machine, right?
Algorithm.
And just like the little child trying to catch the ball, the first one is bound to end up right in the middle of your face, right? And that's simply the way it starts, and that's where you have to take it from. So I guess that's a little bit, we're sort of approaching the end of our second episode around machine learning. We'll be back soon with our third episode, in which we go deeper into actually applying artificial intelligence in all sorts of real life situations. So we truly hope that we have been whetting your appetite to follow us further in this series, and hope to see you back soon. Stay tuned.